Hello, welcome to Unit 6A, Human Nutrition and Soils. This is Part 2, Soil Composition. So when we're talking about soil, it's the uppermost layer of the Earth's crust, and there are 5 different main factors of how soil form. And first is your parent material. This is the rock and the minerals that are actually giving way to this soil. So when you're thinking about igneous versus sedimentary rocks, your igneous rocks are going to break down way slower than your sedimentary rocks. And your parent material can be native to that area. It can be rocks that are brought in through wind, water, glaciers, things like that. Then time, your soil is going to reach maturity, okay, after a certain time through succession. And this depends on lots of different factors. But on average, it takes about 500 years to form 1 inch of soil. That's going to be much longer in certain climates and much shorter in other climates. So climate, you have temperature and moisture. These affect your weathering, your macroenvironmental conditions for your soil organisms, plant growth, decomposition rates, soil pH, chemical reactions in the soil, all which are going to form things slower and faster. In the fastest soil forms with higher temperatures because it acts as a catalyst for the speed of the reaction of things breaking down, and more rainfall, which is going to provide water for chemical reactions. So your warm, wet climates and that have enough of the material present are going to give you better soils. Think about in New Jersey, we have temperate deciduous forests. We have lots and lots of leaves. We have these seasons. We have the thawing and the cracking of the ice during the winter. We have the high breakdown during the summer. So we tend to have really awesome soil. The difference between your physical and your chemical weathering, kind of just review. Your physical has that freezing and that thawing. You have plant roots that are breaking rocks apart. And this is basically you're taking 2 rocks, smashing them against each other. That's your physical. Your chemical is going to change in some way. Your lichens have enzymes that break down rocks. You have chemical reactions that occur with water. And your big example here is oxidation of iron, and it forms a limonite. So basically, it's just one chemical change. Vegetation in organisms is all of the stuff that lives in the soil. If you look at a teaspoonful of soil, there are bacteria, protozoans, nematode worms, springtails, mites, pseudoscorpions, and all different sorts of things that are actually living in them. That's the reason why when we did our experiment with the nitrogen cycle, the stuff in the back that died, we microwaved our soil to make sure we killed all of these organisms. We wanted sterile soil. The larger soil organisms are your worms and your ants. Worms are absolutely amazing. They digest basically the nutrients in the soil and they poop it out. If you look here in the upper right hand corner, this is worm poop. We call it castings. And what worms also do is they aerate the soil with their tunnels, and then that provides space for water and for air to travel to get to the roots. Ants are the same thing. They aerate their soils with tunnels and chambers. And what they do also is they take food from the surface and they leave it underground, and it can either decompose or seeds end up growing from being buried from these ants. Ecosystem services, you have your soil organisms that provide these things. Decay and cycling of organic material, they prevent soil erosion, break down toxic materials, cleansing the water, aerate that soil, especially done by earthworms, but also by ants. Symbiotic relationships, we did a bit with that when we did the nitrogen cycle. You have mycorrhizae, which are fungus on the roots of some plants, which are different from rhizobium. So rhizobiums are soil bacteria that specifically fix nitrogen. Okay, remember our peas, clovers, peanuts, all of these legumes, not potatoes. I don't know why everybody always wants to say potatoes, but potatoes are not legumes. They do not have rhizobium on them. Okay. And mycelium are this thread-like body of the fungus that extends beyond the roots, and that's how fungus actually grows and spreads. All of these are, well, mycelium are the saphotropes. They break down organic material. They're very similar to mushrooms. And last but not least, you have topography. So this is where the soil is formed. And your soil can form faster or slower depending on if you're in an area with more or less wind. What is the slope? When the soil forms, is it going to erode down a steep hill? Or is it in a valley and all of that soil that's eroding off of that steep hill is gathering in that area? Okay? So a lot of different soil forming factors. And then we have our soil composition. Generally, your soil is going to be about 45% mineral particles, your weathered rocks, and you have nitrogen, phosphorus, potassium, different things that provide plant nutrients. Then organic material, your humus, your animal waste, dead remains of plants and animals. This picture that you see here is almost all humus. It is really black. When you have that black, it's dead, decomposing stuff, and this is black gold for your garden. And then the other 50% is really comprised of water and air. You need water in your soil, and you need air in your soil as well. Texture. When you think texture, rub your fingers together. Okay? Think of what something feels like, and that's what we're talking about when we talk about texture of soil. We're talking about the size particles. So you have sand, you have silt, and you have clay, and they're all different sizes. Sand is going to be your biggest. It's like a basketball, your individual particles. Think about being at the beach and then you have gritty sand on your hands, and if you're eating something, it gets in your teeth and you can feel it crunching. You can feel your individual particles of sand. Then in the middle you have your silt. Okay, if we're going to compare these things to real live things in reference to each other, your sand would be a big basketball, your silt would be a softball. It's somewhere in the middle. Silt is usually a darker, it's alluviated from rivers and stuff like that. And then last but not least, you have clay. So if your sand is your basketball, your silt is your softball, your clay is the tip of your pen or your pencil versus a basketball of sand. Clay is the tiniest. You cannot feel the individual particles. It feels like baby powder. Okay? If there's any grittiness in clay, it's clay particles that are clumped together, or there may be some other textures in it as well. Looking at it, if we were going to put them against each other, your clay, your silt, and your sand, you have very fine sand, medium, coarse, very coarse, and then gravel. We're just going to generalize here with clay, sand, and silt. Spaces in the soil. About 50% of the soil is about those pore spaces. Okay, remember 25% air, 25% water. Your spaces allow this water and air to travel through this soil, and your plant roots need air and they need water. So these spaces provide all of this for your plants. Spaces also have to do with permeability. So that's the rate at which water and air move from the upper to the lower soil layers because of gravity. So your pore spaces, the amount of room between the grains, determines your permeability. Okay? You think about blacktop, not permeable, nothing's going to flow through it. And then you think of your soil. Okay? Grass is going to have water that flows through it. Your larger pore spaces drain water much more quickly. There's a lot of space for them to quickly flow through, and your small pore spaces tend to hold the water because what happens is that little particle, okay, let's say we've got water, it's got to find its way through all of these itty bitty particles to get down through the bottom. Whereas with this one, like here, and it's out. Okay, so much of a difference of water actually being able to flow through these. So your sand has large granules, silt is medium, and clay is small, meaning that your sand is going to have large pore spaces, your clay is going to have small pore spaces. Your sand is going to have high permeability, and your clay is going to have low permeability. It's going to take more time for the water to absorb off the top, for it to flow through and come out the bottom. Whereas with sand, you think about pouring water on sand at the beach. It absorbs really quickly, flows through. Then we have loam. This is your mixture of sand, silt, and clay. In a perfect loam, which you can see here highlighted in red, it's about 40% sand, 40% silt, and 20% clay. Okay? These are your different types of soils, and what this is called here is a soil textural triangle. So on the right-hand side here, you have the percent of clay that is in your soil sample, your percent silt on the right-hand side, and your percent sand at the bottom. Okay. What you can do is you can find out what percent of your soil is sand, what percent is silt, and what percent is clay, and figure out what type of soil that you have. Clay, okay, isn't going to be good for much. Loam is ideal. Then you have a silt loam, which is a loam, but it has a little bit more silt in it. You have a clay loam, which is a loam that has a little more clay in it. And sandy loam, which is the state soil of New Jersey. It's a loam, but it has a little bit more sand in it. So this brings us to trying to figure out what type of soil we have based on different textures that we have. So we're going to use this soil textural triangle to figure out what type of soil is represented by these percentages right here. A little hint for this: you will have to do one of these on the AP exam. As a multiple choice, soil textural triangle always shows up. Really easy way to get points. Now the thing is that if you're looking at this silt, how do I know whether I follow this line or this line? For clay, how do I know whether to follow this line or this line? It's very simple. If you notice here, these numbers are slanted. These numbers are slanted, and these numbers are straight. All you do is you follow the way that this arrow underneath your number is pointing. So if we have 55% sand, which is down here, we're going to go 50, 60, so it's right in between. I'm just going to draw a line. Might not be that straight. Then we have 5% silt, which is over here. So between 0 and 10, and I draw my line. So this is the line I'm going to follow. And it's going to go down there. So I have two intersecting. I don't really need to know what percent clay it is. However, if your lines look like mine, you probably do. 40% clay. Here we go. Right here. What this is a sandy clay. Next example. 20% sand, 75% silt, and 5% clay. Take a second. Try to do it. %, sand, 75% silt, and just to check, we have that 5% clay. So you have a silt loam using these percentages over here. The last thing I want to go over are soil properties. So your soil texture affects your soil properties. As we saw, the coarse textured soil, your sandy soil, has large pore spaces. It's not going to hold the water well. The water is going to flow through it very easily. It's going to have a high percolation rate. Now, the funny thing about clay is you have small pore spaces, which means it's going to drain very, very slowly. You're going to have very low oxygen levels in your soil. However, you do want some clay in your soil because clay, it's so small, it has a negatively charged surface. So it's able to hold on to important plant nutrients that are typically positive. So if you look in this picture, you have calcium, you have potassium, magnesium, and what they're doing is they're actually attracted to that negatively charged clay particle. You want a mix of all different types of textures in your soil. You want your sand for your good drainage. You want your clay to hold some water and to hold some nutrients as well. But here it's a fine balance. We don't want too much of something and too little of something else. Okay, but clay is really great because it actually attracts and it holds lots of different nutrients. That's it for today.